This question is about recurrence relations. This is known as a recurrence relation, and it's not as bad as it looks, to be honest, because all it's basically saying is to find the next term in my sequence, un plus 1. I find the current term, and I square it, I minus 8 times it, and I add 17. So what I'm going to do is I'm going to let n equal 1, and then it becomes that u2 is equal to u1 squared minus 8u1 plus 17. I've just replaced all my n's by 1. And when I've done that, I've got u2. And so I can now work it out. I know what u1 is. It's 4. So it's going to be 4 squared minus 8 times 4 plus 17. And that is actually equal to 1. So I found u1. So I found u2. u2 is equal to 1. And now I'm interested in finding u3. Well, now I do the same again. You can just put 1 straight in, but I'm going to do it. I'm going to show it a bit more. Hopefully it's clear. I'm going to let n equal to 2. When n is equal to 2, I'm going to get that u3 is equal to u2 squared minus 8u2 plus 17. Okay, and now I'm going to replace all my u2's by 1, so it's going to be 1 squared, which is just 1, minus 8 times 1, which is just me minusing 8, plus 17. That's going to be 1 minus 8 plus 17, and it gives me 10. So u3 is equal to 10. Okay, let's say I had a different starting term, because you can get all sorts of interesting sequences going on. What happens if u1 is equal to 2? Well, this time I'm going to do it a bit more quickly. u2 is going to be 2 squared minus 8 times 2 plus 17. That's going to be 4. You can actually just put this into a calculator, but I'm doing it without. 4 minus 16 plus 17. That's the same as me just adding 1. I'm going to get 5. u2 is equal to 5. Okay, if I want to find u3, I'm just going to put it back in again. It's going to be 5 squared minus 8 times 5 plus 17. That's going to be 25 minus 40 plus 17. 25 minus 40 is minus 15 plus 17. That's going to equal 2. Now what's going to happen when I put 2 in? I'm going to get the same as I got when I put 2 in before. u4 is going to equal 5. And u5 is then going to equal 2. And what I'm going to get is this periodic sequence, in fact. So what's u100 going to be? Well, I don't want to actually go all the way. I can see that it's going to alternate. It's going to be 2, 5, 2, 5. And all the even ones are 5. Okay, this was u2, this was u4. Even n give 5. So finally, u100 is going to equal 5, and I've justified it as well.